Hey guys, uh, as you can imagine, this problem with the origin of the cut has really been driving me crazy. I just could not figure out what was going on with the mill. It does a cut, looks pretty good, but then it loses its reference point, which is the key to the whole operation. So. I've been scratching my head quite a bit for the past couple of days, and went on the internet trying to find something that would just I don't know, give me some ideas. Couldn't really find a heck of a whole lot. I'm kind of left with two possibilities. Possibility number one is that the cutting implement is pushing a little too hard against the part that I'm trying to cut, and as a result the motor might be missing some steps. Not quite sure how to fix that type of issue except taking a lighter cut, and I'm already down to cutting 25 thousandths, and then that's that's not a huge cut. If the mill can cut that deep, then what good is it? So that's option number one. The other option that I've been thinking is that maybe, just maybe, that if this is the shaft of the motor commanded by the computer to turn, and this is the coupling that is connecting the motor to the lead screw, that it may be that the acceleration of the motor might be too quick. In other words, it would be like if you have a table that has been set with dishes and stuff, and you just grab the tablecloth and just kind of yank it real quick, and if you do it fast enough, you can slide it off from underneath it, without everything falling basically, but everything will slide off a little bit. So it could actually be that the acceleration of the motor, it's fast enough that it overcomes the friction of the coupling momentarily until it catches back on. And I'm hoping that that's what it is, because if that's the case, then there are a few things that I can do fairly easily. So I devised a little experiment. I mean, it's not a big deal, but I figure if I can just set the machine up back like I wanted to do the cuts that we just did, but instead of actually cutting, I just run in with the z-axis up high and cut up in the air, so there's actually no load on the cutting head. I can eliminate that first variable, and if the axis goes back to zero, well, that was the problem. But if the axis does not go back to zero, well, then I cannot blame it on the fact that the stepper motor is missing steps, pushing too hard. It's probably it might have to do with the acceleration of the motor. There might be some other issues there that I haven't thought about yet, but right now the only two ideas that I could come up are those. So what I'm going to do, I'm going to run the program again, air cutting, and take you with me to look at the operation, maybe fast forward a little bit all the way to the end, and then we tell the Mach 3 to go back to zero, and we see where the cutter goes. Again, if it goes anything other than 0, it is the acceleration of the motor. If it goes back to 0, then we have an issue with missing steps. So let's just do that. Alright, experiment number one. We have the part still in the machine. I have zeroed out the position of the cutting tool. 0 on my mill's DROs, and looking at Mach 3, everything is zeroed out there as well. So we're running the same code. I'm gonna hit run and probably fast forward to the end of this code. unless you guys want to see what's going on, but since it's not really cutting anything, it might be a little bit boring. And bear with me for just a second if I can get everything in the same shot. There you go. Right, go. Let's do it. There we go. Now it starts. As you can see, you know, it actually is jarring a little bit. The acceleration I was checking earlier is pretty high. I mean, it's not terrible, but it's pretty high, so I wonder if that might not have something to do with it. But we'll see how that goes, and we'll take it from there. Just a couple more lines. Yeah, 2 more lines of cutting after this, and we'll have our answer. Cycle, which then would repeat going further and further down in the Z-axis until it gets the whole piece. And she should stop right now. And I'll go to the next line of code. It's not quite where it needs to be, but let's see. We're gonna hit. Go to 0 up there. Let's see. Go to 0. As you can see, X and Y are indicating 0. And now let's just look at what Mills DRO said. How about that? Mill DROs indicate that we are 25 thousandths off in the X-axis and 41 thousandths off in the Y-axis, all going to the southwest corner. So what does that mean? I don't know, forget what does that mean. Yeah, that means that it's losing its position even when it's cutting air, and so it cannot be the tool pressing too hard against the aluminum because it didn't even touch it. So that's not the problem. Maybe it's an issue with this big motor spinning too fast for the little coupling that I'm temporarily enclosed down in here. That's obviously must be slipping a little bit as this motor turns a little bit fast. You know, they accelerate a little bit too fast for the coupling to keep up with. So the next thing we can do is reset the machine to 0, and do the same cutting operation again, but after we change the acceleration numbers for the motors in Mach 3. So I'm gonna set that up and we'll give it another go. Hang in there. So I have reset the mill to 0 coordinates, which means that our tool bit is lined up with the southwest edge of the part, and I've done the same thing with the Mach 3 software. And what we're gonna do now is, since we're back at the beginning, everything's set up, we can rerun this program. But before we do that, we're gonna change the motor tuning. Let me bring it up a little bit so you can see a little better. Okay, this is the motor tuning page. This is for the X-axis motor. You can see there's this is how many steps, 10,000 steps for an inch, I think. 120 inches per minute is the speed that I selected. I did that up here in this vertical slider. This is the acceleration, and same thing, acceleration in G's, and you can change that this way. Now this graph indicates how quickly it accelerates up to the 120 inches per minute, and then how quickly it decelerates to back to 0. So what we're trying to change now is this ramp. It's how quickly we get to that speed. And although these numbers are the numbers that came with the Mach 3, information, I thought this would be pretty, just middle of the of the pack type of thing. We're gonna try to slow it down. I mean, reducing the acceleration. Tell you what, we just go all the way to the lowest amount. So this is the best possible situation to avoid what I think it might be happening, which is the motor snapping, to up to 120 inches per minute, and having the coupler slide on the axis slowly. So in this way, this is the best conditions for that not to happen. And if this works, then we can probably just ramp up this acceleration a little bit. But we're gonna try it this way first. So we save the setting for the x-axis. We do the same thing with the with the y-axis, and as you can see, this would accelerate a little faster, and we're gonna accelerate and decelerate as slow as possible. And we save the setting for this axis too. Okay, so now we should be able to run this program, and it might or might not look, a little bit different. I don't know if we'll be able to see the actual difference as the cutting takes place, but I'm gonna mount this camera back in position so you can see the exciting air cutting action taking place. Bear with me for a second. Actually, probably better if I move farther back a little bit. You might be able to see the motor. I mean the motor turning the. I'm sorry, I didn't mean the motor, but the table moving might be less snappy. So that might be a better view. I'm gonna get started and then we'll see if we need to reposition. So turn the drivers on, so it's gonna get a little loud because of the fan. You just heard the motor activate, and cycle start and run, and we should be air cutting any second now. Alright, should be air cutting any moment now. And, the table does look a little bit smoother. It obviously doesn't snap like it used to do before. Yeah, it's actually quite nice. I don't think that would be a problem at all. If I had to do, a lot of cutting, that wouldn't bother me at all. Let's see how it's going over there. So like a couple more lines of cutting, and we should be able to check our DROs. See if I can get the cutter into the picture just so you can see. Okay. Yeah, you might not be able to see it. There you go. So there you go. Let's see. One more line of cutting, and then we should be done. I kind of like it. It's pretty smooth. Speed is really not an issue. You can make it go as fast as you want and just accelerate a little slower or more slowly. So that's the end of that cut. We're gonna make the next line of code, which takes it back near 0. I like it. Very nice, very smooth. Alright, let's see. I'm going to get you guys off of this post, and we have some random numbers up there wherever the cutter stopped, but we're going to tell it to go back to 0 by clicking go to 0. And alright, what do we have there? We have, that's pretty darn good. 0, 0, and minus 1000, which is and what do we got there? 0, 0, 0. So a difference of 1,000, that is like, after all that cutting, is basically nothing. So I think we have a winner here. I think that's probably exactly what it was, an issue where the motor was just accelerating way too fast for the couplings to hold on to the little axle of the motor. So I think I'm gonna call this a winner, and we're gonna get started cutting again, and hopefully we can get to the end of this plate by the end of the next video. Alright, hang in there, I'll see you in the next video.